You ever look up at the stars and just wonder what you're actually looking at? Because it's not just a bunch of twinkling lights, it's history. Every single telescope, in its own way, is a time machine. So, yeah, today we're going to dive right into that. Let's see just how deep this rabbit hole goes. So, let's just get right to it. Are telescopes really time machines? Well, in a very real sense, yeah, they absolutely are. And to get why, we have to talk about light. You know, the one thing in the universe with a speed limit. It's crazy fast, for sure. But the key thing to remember is, it isn't instant. Light just zips along at about 300 million meters every second. It's a number that's almost impossible to wrap your head around. But a light year? That's just the distance that tiny beam of light travels in 1 year. So think about it. If you're looking at a star that's, say, 10 light years away, you're not seeing that star as it is right now. You're seeing the light that left it 10 years ago. You are literally looking into the past. And the farther out you look, the deeper back in time you go. Okay, so if we want to peer into the deepest, oldest parts of the universe's past, we're going to need the most powerful eye humanity has ever built. And that brings us to this absolute beast of engineering, the James Webb Space Telescope, or JWST for short. This thing was designed from the ground up to do exactly that. Just look at this. You can really see what a massive leap this is from Hubble, an icon we all know and love. Webb's primary mirror is nearly 3 times wider. It sees the universe in different colors, in longer infrared wavelengths. And, this is so important, it's parked 1.5 million kilometers away from us, getting it far, far away from the heat and light pollution of our own planet. And the result of that huge mirror, it's just staggering. Webb has about 6 times the light collecting area of Hubble. The best analogy is a bucket for catching rain. Well, Webb's bucket is just enormous. It can catch way more of that faint, ancient light, which lets it see things that are up to 100 times fainter than what Hubble could ever hope to spot. But here's the thing. What really makes Webb a first light machine isn't just its raw power. It's how it's designed. It sees in infrared, which is like having a superpower. It can look right through the thick clouds of cosmic dust that blind other telescopes, showing us this whole hidden universe where stars and planets are being born. To do that, though, it has to stay unbelievably cold. We're talking colder than minus 223 Celsius. Why? So its own heat doesn't blind itself. That combination is what lets it witness the cosmic dawn. Okay, so Webb starts sending back these incredible images from the very edge of time. But it also puts a fascinating puzzle right in front of us. A puzzle that honestly feels like it shouldn't make any sense. All right, here's piece number 1 of the puzzle. Our best science, our best measurements tell us the universe is about 13.8 billion years old. Simple enough. So logically, the absolute farthest we could possibly see should be 13.8 billion light years away, right? That just makes sense. But here's the kicker. The diameter of the universe that we can actually see is about 93 billion light years. Wait. What? How on earth can a universe that's 13.8 billion years old be 93 billion light years across? That does not up. It just feels like a straight-up contradiction, doesn't it? We're told nothing can travel faster than light. And we're told the universe has only been around for 13.8 billion years. So how did it stretch out to be 93 billion light years wide? Seriously, how is this possible? Well, the answer is maybe one of the most mind-bending, but also coolest, facts about our entire cosmos. It's not about things moving through space. It's about the fabric of space itself. This right here is the whole key. The Big Bang wasn't some explosion in space, like a bomb going off. It was the beginning of the expansion of space. The classic analogy is perfect. Think of raisin bread baking in an oven. The raisins, those are the galaxies, aren't moving through the dough. The dough itself, space-time, is expanding and carrying the raisins along for the ride. And we can prove it. This is our evidence. As light travels for billions of years across this expanding universe, the light waves themselves get stretched out. They get shifted towards the red end of the spectrum. We call this
redshift. And by measuring a galaxy's redshift, astronomers can tell exactly how much space has stretched since that light started its journey. That's how we know just how far away and how far back in time these things really are.
So we can see an insane distance away. But is there a limit? Can we just keep looking further and further back until we see the Big Bang itself? The answer is probably not what you're thinking. Surprisingly, no. We actually can't. For the first few 100,000 years, the universe was this super hot, super dense plasma. It was basically an opaque, glowing fog. Light couldn't go anywhere. Photons were just instantly bouncing off other particles. It's like trying to see through a wall. We can't see what was happening inside that fog. This timeline really helps put it all into perspective. So the Big Bang happens, then about 380,000 years later, the universe finally cools down enough that the fog clears and light is set free. Then it takes a bit more time for gravity to do its work. And just recently, Webb spotted a galaxy called JWST Z14-0, shining only 290 million years after the Big Bang. That's our new record holder for the most distant galaxy we've ever seen. So what about that light that was set free when the fog cleared? Well, it's still traveling through the cosmos today. And we can see it. In every direction we look, we detect this faint, uniform glow of microwave radiation. We call it the cosmic microwave background, the CMB. And it is, without a doubt, the oldest light we can possibly see. It's literally the universe's baby picture. All right, so when you put all these incredible pieces together, you get this absolutely breathtaking picture of where we are and when we are in the cosmos. Think about it this way. Our observable universe is a sphere, with us, with Earth, right smack in the middle. But it's not just a sphere of space, it's a sphere of history. When we look at our neighbor, the Andromeda Galaxy, we're seeing it 2.5 million years in the past. When Webb looks at its most distant galaxies, it sees them over 13.5 billion years in the past. And at the very, very edge of our view, in every single direction, is that faint afterglow of creation, the cosmic microwave background. It's kind of a beautiful contrast, isn't it? This shows humanity's two greatest and kind of opposite adventures. With the Webb telescope, we're cosmic historians, peering back to the very beginning of everything. And at the exact same time, the Voyager 1 probe, our little emissary from the 70s, is physically pushing forward, venturing into the space between stars. One looks to our collective past, the other heads out into our cosmic future. And that leaves us with one last, huge, tantalizing question. Our observable universe, as big as it is, has an edge, a horizon. Not an edge in space, but an edge in time. A point beyond which we simply cannot see. But the universe itself? It's almost certainly much, much bigger, maybe even infinite. So as we celebrate seeing all the way back to the dawn of time, you have to wonder, what's out there just beyond the edge of our view?